Hello, they're going to use logarithms today to solve exponential equations, and we've already gone through a process of showing you what logarithms are and how they link to exponentials. And there's a couple of ways to do this, and I'll perhaps try to show you both ways, and you can then make up your own mind as to how you want to proceed. So first of all, a little start for you. Simplify these. I'll do one for you. The log to the base a effectively cancels out with that a to the power of. So this equals 2. It's that simple. And I suppose another one might be the other way around. I'm looking at this. It says x to the log of x to the base of x. So that effectively cancels that, and the answer is 7. So you can guess what a lot of these answers are. So pause the video and see what you can come up with. Okay, hopefully you did pause the video. Hopefully you've got a set of answers. Hopefully they're all written down nicely. And these are my answers, by the way. So I got y. So that cancels that. You got y. I got 5 log to the, now this is something, look, natural log and e, these are inverses. We've seen this. So they're not written as log, but the ln, as some people say. I think Miss Frohbein says ln. That means the natural log. And it's the inverse of the exponential e to the power of. So that's why that still equals 5. Log to base 2, 2. So you can see why that's equal to n. This was y, wasn't it? That cancels that. You can see that. And this is the only weird one, I think. This is 2x plus 1. That's no great shock. But one thing I need to show you is that e to the 0 is 1. 5 to the 0 is 1. 7 to the 0 is 1. Doesn't matter what power you choose. I chose a really weird one there. But it's still 1. And therefore, if I log something to any base, doesn't matter which base, and I get 1 as my answer, then log, I said that wrong. If I take the log to any base of 1, doesn't matter which base, but as I'm taking the log of 1, the answer's got to be 0. The log of 1 is always 0. So that's what that is there for. That's the only weird one. Anyway, so we're now going to do some playing around with functions, and by now we've already, as I've said, shown you that e to the x and log x. I say log x, but lots of people say the natural logarithm of x, or even ln. They just pronounce it ln. It really should be written like this. It's the log to the base e, but no one ever does. Everyone always writes natural logarithm of x or log ln x. So this natural logarithm is important that you understand that it's the opposite of e to the x. Very important that we know this e exists and also this natural log exists. Now, on that basis, let's solve a few equations. The first one doesn't have that in it at all. It just says 3 to the 2x plus 1. And I did say I was going to give you two different methods. So this is the traditional method. This is to take logs both sides. So it's log to the base 3. A log of 3, sorry, to the 2x plus 1. And notice it doesn't say what log I'm taking this to. Usually, if you don't say what it is, it means to the base 10. But no one really minds if you just write log. It means the base 10. So I'm taking logs of the same size. And I'm going to carry on with this convention of not bothering. So 2x. Now, remember my power rule. It says 2x plus 1, but that's a power, so I can bring it to the front. So it's 2x plus 1, and that's times by log 3. And that equals log 80. Notice I can move that over, it comes to divide. 2x plus 1 equals log 80 divided by log 3. And on these new calculators, on the older calculators, you could literally type in log 80 and log 3, but now you definitely will need to type in that. So I want you to use the log button on your calculator, and it looks like this. It says log, and it's got a little square and then a bigger rectangle like that, and you've got to put a 10 in there and then an 80 and then divide it by log of 10 and 3. So type that in. I'm going to do the same thing. So anyway, so menu 1, get in the right mode, log to base 10 of 80, and that is divided by log to base 10 of, what was it, 3. Now I get 3.98. Yeah, 3.988, 2x plus 1. equals 3.988. You could be as accurate as you like. I suppose at some point we're going to have to lose that accuracy. If you take away 1, we get 2.9886, and then divide by 2. And I get 1.49. Notice it wants it to 3 significant figures at the top. So that's my answer, 1.49. Now, to be honest, this is an old method. I wouldn't necessarily recommend you do it this way. I don't know what happened there. So using this alternative method is perhaps now a better bet. We know that powers, exponentials, are the opposite of logarithms. So I can move that 3 onto the other side. Notice it becomes 2x plus 1. And I have to write it, because it's an exponential now, I have to write it as a logarithm. But now, because I moved it straight over, it becomes to the base 3 of 80. And that's because you've got these new calculators have the log to the base 3. The old ones never did, so you could never do it this way, but the new ones do. So, and that goes straight, and notice it goes straight to 3.9886 again. So I've jumped straight to this point in one easy move. So you can see why I'm keen on using this new calculator, the button. Move it over, it's still 2.9886, and divide by 2, it's still 1.49. So look, you can see the amount of work required is much less over here. So from now on, we're going to use that method. 1.49, what bonus? Alright, 2 to the 3x minus 2. Give your answer as an exact answer of log of base 2n. In actual fact, you had to do this properly. You have to do it using the right-hand method of the 2 that I showed you at the start. So the 2 moves over and becomes 3x minus 2, left over on its own. And it's log to the base 2 of what's there, 5. Move the 2 over, 3x equals log to the base 2 of 5. And then plus 2 chucked on the end. Divide by 3. Okay then, so log to the base 2 of 5 plus 2, all divided by 3. And I think that's it. Oh, you can't quite see it at the bottom. This actually says effectively all that divided by 3. So yeah, we got it right. Next question. Harder ones, harder exponential equations. Now notice here I've got 7 to the 2x plus 1, 2 to the x. Now on these you can't play around with it quite so nicely. So notice it says give your answer to 3 sig figs again. So I'm going to write it, 7 to the 2x plus 1 equals 2 to the x. Now this one, I don't have a choice of moving that 7 over and moving the 2 over in quite the same way, because I'd end up with 2 dodgy looking logarithms. So instead of that, I take logs to any one I choose, and I'm going to take it to the base 10. Of 7 to the 2x plus 1. And although the old days I didn't have to write that 10, on these new calculators I think I'm going to have to, so I'm just going to just do it. So log to the base 10 of 2 to the x. But on both of them, and this is the critical thing, both of them I now move those to the front. So it gives me 2x plus 1 times log to the base 10 of 7 equals x times by log to the base 10 of 2. Now on all these equations you always try to get the x's on the same side. So multiply out this bracket first of all. 2x log 10 to the 7 plus 1 times that gives me that equals x log 10 2. I'm going to move that way and that way. I'm going to get 2x log 10 7 minus x log to the base 10 of 2 equals minus log to the base 10 of 7. I'm just going to go up here because I'm running out of room. Notice I've got x and x, so I'm going to take out x as a common factor. It's an important trick to use. Now when I do that, I get 2 times the log 10 7 minus, well, x log 10 2, so just log to the base 10 of 2, close bracket, equals minus log of 7. And therefore the x is that minus log to the base 10 of 7 divided by that bracket. Now you could probably have gone to decimals a lot earlier. So if along the way I thought it was getting a bit complicated, I could have worked this out. It might be 0.4, 18.7, whatever it is. And I could have just carried on with a decimal. It might have been easier to understand what was going on. Anyway, I'm going to type this into my calculator using my fraction button. So it's negative log to the base 10 of 7 over 2 log to the base 10 of 7. And move out the bracket, but still in the fraction, minus log to the base 10 of 2. And on my calculator, when I press equals, I get minus 0.608. Now, I'll be honest, I included the minus on the top. I have no idea if that's right or wrong. Minus 0.608, so that was lucky. It was right. Okay, here's my last question then. What have we got? First of all, and just notice here it says give your answer in the form log p divided by log q. So I suppose that tells me the very first thing I need to do is take logs of both sides, and because there's numbers on each side with powers on both sides, I do need to do that method. So log to the 2 of x plus 3 equals log of 5x minus 1. I should point out here, it normally, most people would say natural logarithm. I suppose I'm one of the few people who says log here. So some people say ln. So you might hear someone say ln of 2x plus 3 equals ln of 5x minus 1. So I don't mind what you say as long as you get the right things in the right places in your answer. So we use the power law, bring it to the front. X plus 3 times log 2, or ln2, is x minus 1 times log, or ln of 5. Same again, multiply out the brackets. X log 2 plus 3 log 2 equals x log 5 minus log 5. So we need to get the x's on the same side. So x log 2 minus x log 5 equals, and this 3 moves over, becomes minus 3 log 2 minus the log 5. So far so good. Take a x out as a common factor, and that gives me log 2 minus log 5. And on this side, I'm going to do it slightly differently. I'm going to move the power back up in reverse. Well, you've seen the power law telling me I can do that. Sometimes you can do that, and this is one of them. I'm going to move it up there. So it's minus power, but I can still say log 2 to the minus 3 minus a log 5. A log rule as well, when they're minusing, remember the minus rule said you are effectively, that makes them divides. So this is log of 2/5. So x times by the log of 2/5 is equal to, and I think I can do the same thing here. 2 to the minus 3, by the way, is the natural log of, this 2 to the minus 3 is an eighth. Minus log 5, and remember when you take them away, you've got to divide them, so it's an eighth divided by 5, which is actually a 40th log of, yeah, because when I do a minus, it will go onto the bottom, so that's a 40th. So I suppose it's simply a case now of division, and it's x equals the log of that 40th. That's got to be divided by that log of 2/5. And if I do that, it doesn't look very nice, but it might be the right answer. So it's the log of 1 divided by 40 divided by the log, and obviously I'm using the ln button, 2/5, and I get 4.02. So just as a guide, that's 4.02ish. I've got log 40. Oh right, now bear in mind, if I was to put log of a 40th to the minus 1 and log of 2/5 to the minus 1, that would turn them upside down. That would give me log 40, but the minus then would have disappeared, and this would be log of 2/5, 5 over 2, sorry. And that might be a better answer. It effectively means I've times top and bottom by minus 1 in doing that, but that's allowed, of course, because it's the same answer. So even though they look different, they're actually identical. You can check that on your calculator. So actually there turns out to be one more question which we'll do in class, but other than that, that's exercise 7C done, and that seems okay to me. So thank you very much.